Today we're going to take R.5 Notes, which is all about rational expressions. I think in Algebra 2 you spend a whole chapter on this, but in college algebra it's one section. So here we go. Here's your definition for a rational expression. It says it's just the quotient of two polynomials. So quotient means division, and you have a polynomial on top, polynomial on bottom. So all of these are examples of rational expressions. Notice on the top you don't see any negative exponents, on the bottom you don't see any negative exponents. So polynomial on top, polynomial on bottom. They're going to ask you to do all kinds of things with rational expressions in this section. Simplify, or I think MyLab says write it in lowest terms. They're going to ask you to multiply, divide, add, and subtract. So we're going to start with simplification, and I see this on the ACT, and kids will just start canceling things, but don't do that. If you see plus or minus signs in the numerator and the denominator, you need to factor first and then cancel your common factors. So look at your numerator, look at your denominator, and see if you can factor both of those. Okay, we're going to start with the numerator. And remember, you look at the first and the last terms and you ask yourself what multiplies to be -8 and adds to be 7. Some of you do this star method over here, so I'm going to set it up like that in case you do that. But you're looking for two numbers that multiply to be -8 and add to be 7. So that's going to be 8 and -1. So those are the numbers that I'm going to replace this middle term with. I'm going to replace 7x with 8x and -1x. Okay, so these two numbers that you find, the ones that multiply to be -8 and add to be 7, which I found to be 8 and -1, those two numbers I'm going to replace this 7x with. So I'm going to rewrite this numerator, but instead of 7x, I'm going to write 8x minus 1x. Now it's just grouping. I just split it down the middle, GCF on the left, GCF on the right. So on the left, I can pull out a 2x, and if I pull out a 2x, I'm left with x plus 4. And on the right, I can pull out a -1. If I pull out a -1, I'm left with x plus 4. And your two factors better be the same on the left side and the right side. If they are, great, you did it right. If they're not, then you did something wrong. So x plus 4 is one of my factors. And then the other factor is what's in front of each set of parentheses on the left and the right. So 2x minus 1. So those are the factors for the numerator. And now I have to factor the denominator as well. Okay, now I'm looking at the denominator, and I don't have to do all of this business that I did for the numerator. I noticed that it has a GCF. My GCF is 5x, so I'm going to take out a 5x. So now that I've factored the numerator and the denominator, I look to see if they have any factors that are exactly the same. They have to be exactly the same. And I do. I have the x plus 4, so it cancels on the top and cancels on the bottom. So my final answer is 2x minus 1 over 5x. Okay, here's another one. You're simplifying. Pause the video and try it. Try to factor first, factor the numerator, factor the denominator, and see if anything cancels. So maybe you came up with this. You factored a 3 out of the numerator, and you realized that the denominator was a difference of 2 squares. So you could just split it up into x minus 2, x plus 2. And you're looking at your factors and seeing if there's anything the same. These look like so close to each other, but they're not the same. On the top, the x is negative, and on the bottom, the x is positive. On the top, the 2 is positive, on the bottom, the 2 is negative. So they're very close, but they are not exactly the same, and so you cannot cancel them. But you can get a little creative. Instead of taking a 3 out, you could have taken a -3 out. So if you're doing one of these and you see a factor that's really close, they're opposites of each other, try taking out a negative common factor. So now if I take out a -3, that makes that a -2 plus x. Now they're the same. The x's are both positive, the 2's are both negatives. Now I can cancel them out. Final answer, I have a -3 on the top, and on the bottom I have x plus 2. Next up, multiplication. When you multiply fractions, you do not need a common denominator. You just multiply the tops, multiply the bottoms. So if I'm looking at number 3, I can go ahead and multiply the numerators. I can make that 54y squared. And then on the bottom, I can multiply the denominators and make that 72y to the 5th. I could do that and then simplify. Or you could simplify first. So I like to simplify first so then I don't have to worry about such big numbers. So for example, this 2 and this 8, I can reduce those. I can divide both of those by 2. So if I divide both of those by 2, this becomes 1, this becomes 4. Same thing with the 9 and the 27. I can reduce those. They're both divisible by 9. So if I do that, this becomes 1, this becomes 3. And you can leave it like that at first, or you can go ahead and do the y's. So I'm going to leave it like that at first. So on the top, I have 3y squared, and on the bottom, I have 4y to the 5th. And I hope you know that these two y's on the top will cancel with 2 of the y's on the bottom. So that's going to become y cubed because I had 5 originally on the bottom, but I can cancel out 2 of them. So that's final answer is going to be 3 over 4y cubed. Number 4 is still multiplication, but it's uglier. So I'm going to try to simplify it first. And before I simplify, I have to factor. So I'm going to factor everything that I possibly can, and then hopefully stuff is going to cancel out. So let's start with this first numerator right here. Remember, I'm trying to find two numbers that multiply to be negative 24 and add to be negative 2. Okay, I'm going to show you my factoring. Like I said, you're going to try to, you take the first and the last two and you multiply those together. So I'm going to find two numbers that multiply to be negative 24 and add to be the middle one, add to be negative 2. So I set up this little thing over here. I'm going to show you my factoring. So now I'm going to rewrite this numerator, but my two magic numbers, negative 6 and 4, because those are what multiplies to be negative 24 and adds to be negative 2, those two magic numbers are going to replace this middle term right here. And now I just group. I split it down the middle, GCF on the left, GCF on the right. So my two factors are m minus 2 and 3m plus 4. And that's just this numerator, this very first numerator. Now you try it for this denominator here. So you're trying to find two numbers that multiply to be 24, but this time add up to be 14. So you try that and see what you get for your factors. Okay, I'm not going to walk you through it, but I did show my factoring over here on the right-hand side for that denominator. So your two factors should be m plus 4 and 3m plus 2. So now I'm looking at my multiplication over here, and I'm trying to find stuff that will cancel. So when you're multiplying, this does not work for addition and subtraction, but when you're multiplying, you can consider this as one giant fraction. So all of these factors on top, all of these factors on bottom, you're trying to see if there's anything the same on the top and the bottom. So this 3m plus 2 is going to cancel, and this 3m plus 4 is going to cancel. So your final answer is m minus 2 over m plus 4. Okay, number 5 is division. So that's a little spicier than multiplication. Let's take a little trip back to, I don't know, 4th or 5th grade. When you first learned to divide fractions, it was like, let's say I had 1/5 divided by 2/3. Do you remember you had to keep, change, flip? Did your teacher ever tell you that? So you keep the 1/5, you change division to multiplication, and you flip the second fraction. Then it looks like multiplication. You multiply the tops, you multiply the bottoms, so it ends up being 3/10. Okay, same concept, but uglier. So before I forget, I'm going to keep, change, flip this thing. So I'm going to keep this first fraction, change my division to multiplication, and flip this second fraction. So I'm going to do that first. Okay, so now it looks like the last one we did. It's multiplication, but before I multiply anything, I'm going to factor first, and hopefully stuff will cancel. So take a minute, pause the video, factor everything that you can possibly factor, and let's see if anything cancels. Okay, I did my first numerator. I did all my factoring over here. So hopefully your two factors were p plus 4 and 3p minus 1. Okay, now the rest of them, they all have GCF. So this denominator right here, this first denominator, look at both terms and see if it has a GCF, and it does. I can take out an 8p squared. This next numerator also has a GCF. Maybe some of you are thinking 3 or 4 or 6. Go big. 12. Let's do 12. P cubed is my GCF, so let's take that out. And the second denominator, once again, go big. Don't pick 3. Go big or go home. 9 is your GCF. Okay, so now I'm going to look across. I'm going to look across the numerator, look across the denominator, and see if there's anything I can cancel. So I see that I have a 3p minus 1 that I can cancel out. I have a p plus 4 that I can cancel out. Let's write down what I have so far. So on the top, I have 12p cubed times 2p minus 3. On the bottom, I had to multiply this 8p squared times 9. That's where I got my 72. And then I also had a p squared. Okay, so I could have canceled before this, but right now I have 12 over 72, so I need to reduce those. So both of those are divisible by 12. So if I divide the top by 12, I get 1, and the bottom I get 6. And then you can look at the p's. P squared I can take out of both of them. So p squared goes away on the bottom, and if I take out a p squared on the top, there's only going to be 1p left. Okay, final answer right here. Don't forget to reduce. All right, I'm going to stop this video. This section, R5, is going to have 2 videos to it because I've already gone too long. All right, make sure you watch the next video.